Welcome. Euler's method, numerical practical by C programming, problem number 24. Write a C program to solve the following initial value problem by Euler's method to find the value of y for x equal to 0.1, increment 0.1 up to 0.5, correct to 5 decimal places. dy dx equal to fxy, and this is the function 1 plus x square plus x is 1 plus x y plus x square y square plus x cube into y cube whole to the power 3 by 2 whole divided by 1 plus xy plus x square plus y square whole to the power 1 by 2. Y 0.1 equal to 1.1 plus r by 10. R is the last digit of your roll number, CU roll number. Now consider a first order differential equation dy dx equal to fxy. So fxy represents the slope at this point xy with the initial condition y x0 equal to y0, where fxy is a given function, either may be linear or non-linear function, and this is an initial value problem. The Euler's method is a single step method for solving the ordinary differential equation 1. What is the single step method? Here the value of yi plus 1 depends on the knowledge of the preceding value of yi only. Then we say this method is single step method. We have to find the approximate values of y at equally spaced points x1 that is equal to x0 plus h, x2 that is equal to x0 plus 2h, and so on, xn equal to x0 plus 8h. H equal to xn minus x0 by h is the step length. Now y1 equal to y at the point x0 plus h, by expanding by Taylor's series about x0, h is very small, equal to y x0 plus h y dash x0, this derivative with respect to x, and y a function of x, plus h square by factorial 2 y double dash this x0 plus theta h, 0 less than theta less than 1. This is the remainder term. Neglecting the order of h square due to very small positive quantity h, we get y1 equal to this approximately equal to y x0 plus h y dash x0, that is y0 equal to y0 plus h into f of x0 y0, because y dash means dy dx at the point x0, so dy dx means fxy, so this equal to h fx0 y0. And similarly we can find y2. Y2 means the value of y at the point x2. X2 means x0 plus 2h. This is equal to y1 plus h into f of at the point x1 y1 etc. In general we can write y I plus 1 equal to yi plus h f of xi yi. I runs from 0 1 2 up to n minus 1, and this is the geometrical uh, significance of this interpretation of this uh, Euler's method. This is the curve. This is the curve y equal to fxy in blue color, and this is the point. This point is x0, and this height is y0. So this point is x0 comma y0, and this is the step length h. So this point is x1, and at this point this y dash x0, that is the slope of this curve at this point x0 y0, and this point is at this point x1 y1. So this height is y0, and this is the h into f x0 y0. This is the tan theta of this. This by this equal to tan theta, and so on. Dy dx equal to this height by this height h. So this equal to h plus h into f x0 y0 at this point. So actual value of this x at the point x1, actual value is this y on the curve this point, but approximate value by Euler's method, and this is the corresponding height of y1. This is the numerical uh, value of this point uh, at the point x1 of this. So this is the geometrical interpretation of this and these Euler methods. And we first we define the function fxy. These are function float x and float y. Depends on this, we return the function this power 1 plus xy plus x square into y square plus x cube into y cube whole to the power 3 by 2 whole divided by 1 plus xy plus x square into y square whole to the power 1 by 2. Here the floating variables are x0, y0, the initial value of x, initial value of y, and xy, h is the step length, xn is the last value of x, and k k is some float variable k, and this integer variable r, the last digit of your roll number. This is the enter the value of r. This here x0 equal to 0.1 given in this question, and enter the initial value of x0 and scan f, this is the x0. So remove this line, and the corresponding y0, this corresponding y0 equal to the initial value of y, this 1.1 plus r by 10. This is the given value of y0. So initial value of y0 is this, and the x0 equal to 0.5, xn is equal to 0.5 is given that last value of x up to this final value of x, xn, that is xn. So h is the step length also given here in the question, xn equal to this. So in this question xn equal to this, because x equal to 0.1 is the starting from 0.1 up to final 0.5 increment within brackets 0.1. So h equal to 0.1. Enter the step length, and this is the x equal to x0, y equal to y0, and print f, this is the percentage 4.2 format f. This is the float variable 0. Percentage 8.5 float, the corresponding y variable, and while x less than xn, then k equal to this h into f xy, and increment of y equal to y plus k, and x equal to x plus h, and print these x and y. So save and compile and run. So enter the value this 0, say, so this equal to, enter the initial value say 0.1 is given, and initial value of y0 equal to 1.1. Enter the final value of xn, it is given that 0.5. So put xn equal to 0.5, and the step length, enter the step length h equal to 0.1, and this equal to this is the result, x corresponding x 0.1 is this 1.1, fx value of fx 0.2 is this 1.21241, 0.30 1.34468, 0.40 1.51125, 0.50 1.74228, and this is the Euler's method. Thank you for watching this video.